Hey guys, we're going to kill two birds with one stone, or two lessons, or essentially we're going to be graphing and doing transformations all in once. Okay? So let me get my handy dandy pencil here. Ah, perfect. Boop. So, how can I graph quadratic functions as transformations of the function? Again, what is the name of this shape? This is not a U shape. Okay? Not a U shape. It's a parabola. Or as we say, parabola. Where's the vertex? In class we discussed that it was 0, 0. Okay? It's always going to be the lowest point of a parabola or the highest point of a parabola. Okay? We'll have examples later. Boop. Oh, fun fact. This, make it red, this is the axis of symmetry. It goes straight through the vertex. Yes, this is the y-axis. The equation for the y-axis is x equals 0. For every point on this line, x is going to equal 0. Okay? Boop. So, you can ignore the box for now, but here's our parent function. To get it, we are simply going to plug in the negative 2 where the x is. Again, in class we discussed how this and this are two different things. Be very careful. When we're plugging stuff in, you need to use parentheses. Okay? So negative 2 squared is 4. Negative 1 squared is 1. 0, 0, 1, and 4. And if you notice over here, the points correlate to what we just said. Negative 1, 1, boom. 0, 0, 1, 1, and then 2, and then up 4. Okay? This is the parent function. We're going to feed off of this to see the other transformations. Boop, boop. For example, we're going to add 1 to x squared. So if we were to plug in negative 2 where the x is, we would have negative 2 squared plus 1. Negative 2 squared is 4. 4 plus 1 is 5. Do the same thing for the rest of them. Negative 1 squared is 1. 1 plus 1 is 2. Okay. 0 squared. That's just going to be 1. And what I want y'all to notice is we have a pattern here. 5, 2, 1, 2. This last one should be 5. 2 squares, 4, plus 1. Indeed it is. Okay. So if we were to graph these points, you'll notice it jumped up 1 unit. Okay. Jumped up 1 unit. Why do you think that? Probably because we added 1 to it. Okay. Again, these are inputs. X's are inputs. The Y's are outputs. Negative 2, 5 is a coordinate point that lies on this graph. See, it's right up here. Let's keep going. Adding makes us go up. What do you think subtracting is going to do? That's right. It's probably going to mean it's going down. Let's check this theory out. Negative 2 squared minus 2 should equal, let's see, negative 2 squared is 4. 4 minus 2 is 2. Negative 1 squared minus 2, well, that's 1. Negative 2 equals negative 1. Plug in 0 squared minus 2 is negative 2. And that's right. We'll have a pattern. Good, 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 good. Glad we're seeing the pattern. Plot your points. Skadoosh. And as you can see, it did go down 2. So subtracting makes the graph move down. Again, these are constants over here, okay? So, for your notes, okay, go ahead and pause the video. Take all the time you need because you just paused the video and jot down whatever it is you need. This is the major point here. K units up if K is positive, K units down if K is negative. These are vertical shifts. Okay, cop down what you need and we'll move on. Also, this last sentence down here is just something about common sense, okay? If it's up, it's positive, down, it's negative, okay? Boop. All right, notice now we have something different. We have x plus 2, and we have parentheses, and all of this is being squared. So if you were to plug in -4, again, I picked these x's for a reason. You'll see why in a second. So -4 plus 2. Again, doing some mental math. -4 plus 2 is -2. -2 squared is 4. Again, making my substitution. -3 plus 2 is -1. -1 squared is 1. Again, you can plug this in your calculator, but let's face it, mental math over here. -2 plus 2 is 0. 0 squared is 0. And for those of you who caught on, we do have that pattern again. So we'll just cut to the chase. Plot your points, and look what happened to our points. They all move to the, that's right, the left. Okay. Now, I'm asking you, is there anything surprising about this? Yes, this is a positive. Generally, when we have positives, we go to the right. But this time, our graph is telling us, no, sir, it went to the left. Okay. And the reason I picked -4 through 0 was because I know it was going to come over here. If I were to pick the same points, we would have points up here that we can't graph. Notice the vertex is still in the middle. -2, 0. -2, 0. So this concept we need to keep in mind. Opposite, going back to that idea of strange things in parentheses. This graph shifted to the left even though it was positive. Now with that mindset, let's move on to this next one. If we were to put a -3, excuse me, if we were to put a -3 there, intuitively, we should think that this parent function is going to go to the right. So, real quickly, plug in our points. 1 minus 4. What am I saying? I'm already trying to give you the answer here. Boop. Let's try that again. 1 minus 3 squared. Mental math. 1 minus 3 is -2. -2 squared is 4. 2 minus 3. Again, I picked these x's for a reason. 2 minus 3 is -1. Square 1. And yeah, if you got the gist of it, you'll see it's 41014. Okay, plot your points. Boom. As you can see, the graph moved to the right as we predicted. So negative goes to the right, the positive, the plus goes to the left when we see these parentheses around the x and it's being squared. So let's take some notes on that. Okay, we're introducing the h idea. Okay, shift horizontally. Notice that there must be a minus sign between the x and that h. Okay, the idea is that strange things happen in parentheses. We're going to be pulling the not positive, we'll be, changing the signs. So, h units right, if you see x minus a number, you might want to write that down. H units left if you see x plus a number. And again, why is this strange? Because strange things happen inside parentheses. Might be a fun way to remember that opposite idea. Right when it's a negative, left when it's a positive. Do not confuse this with the previous lesson about going up as positive and down as negative. Okay? These are rightly so. These make sense. This is the one where you got to think opposite. Okay? Stranger Things. Boop. Stranger Things. All right, let's keep going. So, let's practice. Go ahead and pause the video and try to write some equations for these two graphs. All right. So, the graph, just keeping it simple, the graph went to the right. So, we should have x minus 1 squared. This graph went down 4. So, x squared minus 4. Okay. Again, think opposite. We went to the right, so this needs to be a minus sign. Again, pause the video, try these out. All right. This one should be y equals x positive 2 plus 2 squared. This one went up, so y equals x squared plus 1. Plus 1 makes it go up 1. This adding 2, in the parentheses here, makes it go to the right. All right, let's keep going. And look, here's us a good combo. Think about what it's doing. Right, left, up, down. Good. It went to the right 1, and it went down 2. So we know we're subtracting 2 over here. But since we went to the right, we need to subtract 1 in that parentheses. Okay? With practice, you'll get better at this. So, at this point, you can pause, copy these examples, try to figure out the transformation, hit play, and we'll check your answers. Whew! All right, here we go. I'm going to keep it real quick and simple. We're subtracting 3, so we went down 3. We're subtracting 3 in the parentheses. That means we went to the right 3. Positive 3, we going up. Positive 3 in the parentheses, we're going left. This is a combo. This means we're going right. This means we're going up. So right 3, up 3. Let's check my answers. Shifted down, check. Shifted right, check. Left, up, right, and up. Boom. We'll handle those later. Let's keep going. Trying to make sure this video is not too long. And it's getting to that point. We talked about these in class already. Again, this means, whoops, let me get my marker going. Boop, 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 bam. This idea means we're going to the right. This means we're going up. To write an equation for this bad boy, we went to the left 3, and we went down 1. So I know it's a minus 1 out here. Opposite, x plus 3 squared. Let's keep going. I'm going to see if I can make this video under 20 minutes. We're revisiting the parent function idea, and we're seeing the transformations applied. So in this one, we're doing minus x squared. Okay, big difference. Watch this. If I substitute the negative 2 in, it's minus, or negative, a negative 2 squared. The negative 2 goes where the x is. Okay, I'm substituting. So negative 2 squared is 4. Throw on the negative, we get -4. Okay. Again, -1 squared is 1. Throw on the negative, -1. This is just 0. 1 squared is 1. Throw the negative on it. 2 squared is 4. Throw the negative on it. And if you notice, our graph reflected over the x-axis. Okay. Oops. Didn't mean to do that. It reflected over the x-axis. Okay. So for our rule, if there's a negative out front, it causes it to reflect. Here's your notes for that. We're introducing the A now. A is negative. The negative will produce a reflection over the x-axis. Again, pause the video as needed. So if A is positive, the graph opens up. If A is negative, it opens down. So put a little big negative sign in there. You can put a big plus sign here if you wish. Whatever floats your boat, whatever helps you remember what's what. I tend to relate this to a valley, the positive, this one to a mountain, or a cup filling up and a cup you dumped out. Whatever helps, okay? All right, let's keep going. Now we're going to incorporate a +3 in front of the x squared. So again, throw in the substitution in there. 3 times -2, because x is our input, squared. Do the exponent first. -2 squared is 4. 4 times 3 is 12. Again, it's mental math. Throw -1. -1 squared is 1. 1 times 3 is 3. 0, it's just 0. 1 squared is 1. 1 times 3, 3. You see the pattern should be 12. 2 squared is 4. 4 times 3 is 12. So let's look at the graph. Boom. Notice it got skinnier or narrow or thinner. Whatever word you want to use for that. Mathematically speaking, we're going to say it stretched. Okay? Kind of like what I said in class about silly putty being stuck to a newspaper. Peel the silly putty off. You can pull that image. You stretch it out. It makes it thinner. Now, if whole numbers will do that, what do you think this fraction is going to do? Let's find out. Again, 1/2. Substitute the -2 in and square it. So -2 squared is 4. Half of 4 is 2. Put in the -1. -1 squared is 1. Half of 1. Well, it's half, so 0.5. Ooh, that's a point. Oh, my good grannies. There you go, 0.5. 0, duh, 0. 1 squared, 1. Half of 1 is a half. And then 2 squared, 4. Half of 4, 2. So let's look what the graph looks like. Indeed, it did get wider. Okay, the graph got wider. In mathematical speaking, we're going to say it shrank. Okay, stretch, shrink. So for your notes, if A is greater than 1, whoops, if A is greater than 1, it's going to stretch. If it's between 0 and 1, it's going to shrink down. Okay, so if you want to add some notes to some pictures here, again, pause the video as needed. This is a stretch, and that's because A is greater than 1. This over here is a shrink because A is between 0 and 1. Okay, shrink, stretch. Now, I have a slide that catches every single transformation for these quadratics in vertex form. Probably going to want to copy it. Here it is. Quadratic transformations. And when you write these transformations, you got to go in order. Start with the negative. The negative controls if it's reflecting or not. When you're done with that, you look at the A. The A is going to control whether or not it stretches if A is greater than 1, or if it shrinks because A is between 0 and 1. Okay? Once you're done with the A, you move on over to the horizontal shift, H. And look up here at this arrow. If it goes left, that means it's positive H. If it goes to the right, it means it was a negative. Okay? Again, the K, the first thing we talked about, if it's positive, it's going up. If it's negative, it's going down. Here's your parent function. This is what we're working with. And you're going to want to add just one more little note up here. I think it's nice right here. Your vertex comes from the H and the K. Okay? When you pull the H out of the parentheses, you need to change signs. Just like we did when we were doing the factoring, we would change signs because of the parentheses. Again, strange things happen. Change the signs. Opposite. Think opposite with the parentheses. So go ahead, pause the video, copy this ever so neatly. This is essentially your cheat sheet for this quiz. This is all the transformations. Again, pause as needed. Let's look at some examples. Oh boy. So, for each of the functions below, identify the vertex, axis of symmetry, and transformations. Ooh, our video is getting too long. We need to wrap this up. So pause the video, copy, try them out. Use the cheat sheet we just copied. All right, here we go. This is how I would look at it. Vertex. My notes say it's the H and the K. Well, there's no H. So the fact that there's no H, that means it's 0. Here's K, it's 2. Boom. That's my vertex. Axis of symmetry goes through the vertex. So it's going to be X equals 0. I pulled the 0 from the X part of the vertex. Now look at the equation. Negative out front here means we're reflecting. There's no H, so we'll skip that. Oh, I forgot the 3. 3 is greater than 1, so we're stretching. All right, now there's no H because now we're on that part. Go to the +2. That means we are going up. Shift up 2. Okay. Change colors for this next one. We look. This time there is an H. It's a -3. We need to pull the opposite out. But if we look at the tail, there's no K. So essentially that's 0. Axis of symmetry is whatever the X value is for the vertex, so 3. Start, there's no negative, so we don't have a reflection. Half is less than 1 between 0, so that means we're shrink by half. We have an H. You gotta think opposite, so that means we're going to the right 3. So shift by 3. I need to put right somewhere. We'll put right up front. Right shift by 3. There we go. That one's done. Change colors again. I don't know, green, I guess. So, vertex. We do have an H. It's opposite. So, -4. We do have a K. -1. Notice we did not change the K. We only changed the 4 because that's what we discussed earlier. X should be the axis of symmetry. It's going through the negative 4 there. Boop. So there's no negative. There's no stretching or shrinking. Now we're in the H part. So that plus 4 means we go to the left by 4. Excuse me. It's getting pretty late, if you can see the time on my computer. Negative 1 means we went down 1. We'll do blue again. Vertex, no H, so 0. There is a 3. 3. Axis of symmetry, you should be picking it up by now. No reflection. There is a shrink, because that's less than 1. No H, so no horizontal shift, but we do have a K, and we went up 3 because of that plus 3. Alright, I'm going to use red for this one. Vertex, opposite. So 1, 4, comma. Axis of symmetry, this is an X. Equals. What? Oh, sorry, I'm real sleepy. 3. So we have a stretch because it's 3. That's greater than 1. You got to think counterintuitive, so to the right by 1. We got a 4 here, so we're going up. 4. Last one. I put in black. Vertex. No H, so we have a 0. Negative 14. Axis of symmetry is 0. We're going to have a reflection now because there is a negative out front. No H, so no horizontal shift. That minus 14 means we're going down 14. There you go. That's just a matter of practice. Oh, good grannies, I'm sorry, I'm sleeping. We'll tackle this some other time. We'll talk about this in class. We'll do this together, but this is literally a breakdown on how you can graph, and we talk about axis of symmetry. Alright, I'm calling it quits. Some of us are going to the promised land. Texas.